faster than space-time can cope, the looming fate of Polaris. There's growing concern that something is unfolding faster than the very fabric of space-time can keep up with, and it may result in a cosmic tear. Personally, I find this unsettling. Our night sky is rapidly changing, and within mere decades, or perhaps even years, it could become completely unfamiliar. Astronomers around the globe are sounding the alarm. Notably, astrophysicist deGrasse Tyson has confirmed that Polaris, our North Star, is on the verge of dramatic transformation, and the reality behind it is deeply troubling. For centuries, Polaris has served as a constant beacon in the northern sky, helping sailors, stargazers, and scientists navigate the vastness of Earth and space. But this long-standing celestial reference point may soon vanish, leaving a permanent mark on how we view and measure the night sky. Let's delve into the significance of this development and what it could mean for all of us. Polaris, a guiding light, nears its final chapter. Polaris has held a sacred place in astronomy and navigation for generations. Located nearly directly above Earth's North Pole, it has appeared nearly fixed in the sky, earning its place as a pole star. Nestled in the constellation Ursa Minor, the Little Dipper, Polaris is a yellow-white supergiant, far larger and more luminous than our Sun. However, Polaris isn't a lone star. It's part of a complex triple-star system. Polaris A and Polaris B form a binary pair, while a third star, Polaris, orbits closely. Gravitational interactions between them influence their orbits and even affect the star's brightness. Disruptions in this delicate gravitational balance may lead to irregularities in Polaris's pulsation patterns, something astronomers are closely watching. Polaris lies about 323 light-years from Earth. The light we see from it today began its journey centuries ago. This means that if Polaris has already exploded, we wouldn't witness it for another 300-plus years. It's entirely possible that its fate has already been sealed, and we just don't know it yet. Why Polaris matters more than most stars. Throughout human history, Polaris has been far more than just a star. Ancient mariners relied on it for orientation across vast oceans, and countless cultures viewed it as a symbol of constancy and guidance. For astronomers, it's been a vital point of reference, especially in the study of celestial motion and variable stars. As a Cepheid variable, Polaris pulsates in brightness at regular intervals. These pulsations help astronomers measure cosmic distances and calibrate instruments with high precision. Yet recently, Polaris has begun to deviate from its long-established rhythm. Rather than its usual steady pulsation, Polaris now exhibits erratic cycles of brightening and dimming. This behavior has puzzled scientists and prompted a closer investigation into its status. The slow but steady elongation of its pulsation period, now increasing by 4 to 5 seconds each year, is a subtle yet significant signal. While some astronomers believe gravitational forces within the system are causing this, others fear it's a sign of imminent collapse. The supernova parallels. Is Polaris the next Betelgeuse? Polaris isn't the only star behaving strangely. Betelgeuse, the red supergiant in Orion, has also shown baffling fluctuations in brightness, sparking speculation of an impending supernova. The similarities between Polaris and Betelgeuse have only heightened concerns. When massive stars near the end of their life cycles, they often become unstable, showing unpredictable changes in brightness and size. This instability is a hallmark of the final stages before supernova. Polaris appears to be undergoing such changes, suggesting it may be entering a critical phase of stellar evolution. That said, there's a key distinction. Polaris is not massive enough to end in a typical supernova explosion. What happens if Polaris dies? Should Polaris reach the end of its life, it will not explode in a fiery supernova. Instead, it will exhaust its nuclear fuel and gently shed its outer layers, eventually becoming a white dwarf, a small, dense remnant of its former self. This transformation would be far less violent than a supernova, but no less significant in astronomical terms. Once Polaris dims into a white dwarf, it will no longer be visible to the naked eye. Its guiding light will be gone, altering not only our cultural and historical reference points, but also how we study the heavens. Looking back to look ahead, lessons from past supernovae. To better understand Polaris's potential future, scientists are examining past supernova events like SN 1054, which formed the Crab Nebula, SN 1987A, and more recent cases, such as SN 2011F and SN 2024J. These events offer crucial insights into how stars evolve and how their remnants shape the universe. When a supernova occurs, it hurls vast amounts of matter into space, enriching the interstellar medium with heavy elements. These remnants often form glowing nebulae, stellar nurseries that give rise to new stars and planets. While Polaris is unlikely to explode in this manner, its fading may still influence the surrounding cosmic environment in more subtle ways. By comparing its behavior to these well-documented events, scientists can better predict Polaris's long-term legacy, be it as a white dwarf or a faded echo of a once great star. Conclusion: the end of an era in the night sky. While the potential demise of Polaris may not pose a direct threat to Earth, the emotional and symbolic impact would be enormous. Losing the North Star would mean the end of a celestial era, one that has guided humanity for millennia. If Polaris does vanish from our night sky, it will leave behind not just darkness, but also questions, insights, and awe. The story of Polaris is not just about a star. It's about how we understand the cosmos, measure our place in the universe, and navigate both literally and metaphorically by the light of ancient suns. As Polaris nears its final chapter, we're reminded that even the most steadfast lights in our sky are not eternal. The universe is always in motion, and so, too, must our understanding evolve with it. Material accelerated by the shock wave of a supernova plays a crucial role in shaping astrophysical processes and influencing environments exposed to cosmic radiation. To draw meaningful comparisons, scientists examine differences in the mass composition and velocity of ejected material between the predicted eruption of Polaris and previously documented supernovae. This involves analyzing light curves, spectral data, and remnants from earlier explosions to project comparable features for Polaris's anticipated outburst. Researchers also explore whether Polaris's potential explosion could lead to the formation of nebula or generate unique elemental distributions, factors that deepen our understanding of its likely consequences. Another critical area of inquiry is the pulsational variability observed in stars nearing the ends of their life cycles. By comparing Polaris's irregular pulsations to those of supernova precursors, scientists hope to identify patterns or anomalies that shed light on the underlying mechanisms driving stellar eruptions. These pulsations often point to internal instabilities or looming catastrophic events, serving as indicators of the processes that culminate in a supernova. Yet despite extensive observation and analysis, Polaris continues to perplex astronomers with its erratic behavior. Understanding the reasons behind these irregularities demands interdisciplinary research, advanced theoretical modeling, and more sophisticated observational tools. The potential loss of Polaris, a key navigational anchor and cultural symbol, raises significant concerns. Ground-based telescopes and celestial measurement systems will require recalibration, potentially disrupting the accuracy of astronomical calculations. Navigation systems and traditions tied to Polaris as the North Star would also be affected, highlighting the broader implications of such a cosmic transformation. Polaris's strange activity calls for urgent and focused scientific attention. Astronomers must decode the complexities behind its pulsations to gain clearer insights into stellar evolution. While its fate remains uncertain, the pursuit of answers in the face of cosmic ambiguity is a powerful reflection of humanity's enduring quest for knowledge. This situation also prompts broader questions about the future of other stars. Polaris and Betelgeuse are just two examples of the many stars undergoing dramatic changes. Countless others are in similar evolutionary phases, particularly red giants that display instability, fluctuating brightness, and irregular rhythms, signals that they may be nearing the end of their life cycles. These stars offer invaluable opportunities to study the final stages of stellar development and the triggers of supernova explosions. Beyond individual stars, astronomers also turn their focus to star clusters, environments where groups of stars evolve together under shared conditions. These clusters reveal how gravitational interactions and material exchange can influence stellar life cycles, including phenomena like mass transfer between stars that may alter their evolutionary paths. Lastly, Studying the remnants of supernovae provides essential insights into the nature of these powerful events. When massive stars explode, they not only leave behind stunning visual relics, but also enrich the cosmos with heavy elements and clues about the forces shaping the universe. Supernovae unleash vast amounts of material into space, enriching the interstellar medium with heavy elements that play a crucial role in forming new stars and planets, demonstrating the deep interconnectedness of the universe. The remnant of these stellar explosions often manifest as nebulae, which act as nurseries where new stars are born. By observing these processes, astronomers can piece together the grand cycle of cosmic birth, death, and rebirth. The impact of supernova extends far beyond its immediate surroundings. These explosions can influence star formation rates across entire regions, affecting the development of galaxies themselves. The powerful shock waves they produce can compress nearby gas clouds, triggering the creation of new stars. In this way, the life and death of a single star can ripple across the cosmos, shaping galactic evolution over billions of years. Thanks to technological advancements, astronomers are now better equipped than ever to study these extraordinary events. Space telescopes and ground-based observatories use advanced instruments to capture high-resolution images and spectral data from distant stars. This information helps scientists build detailed models of stellar evolution and forecast the behavior of stars like Polaris. Moreover, machine learning and AI are increasingly instrumental in processing large datasets, revealing patterns and insights that were once hidden. Beyond their scientific significance, astronomical phenomena have long held cultural meaning. Throughout history, events in the sky have influenced mythology, spiritual beliefs, and even navigation. The North Star, for instance, has served as a timeless symbol of direction and hope for generations. As our understanding of the cosmos deepens, so does our appreciation for how these celestial events shape both the universe and the human experience.